Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 6 Trigonometric Functions, Long Question Example 4. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Prove the identity where 2 sine 45 degree minus x cos 45 degree minus x equals to cos 2x. So this is for the question part A. For the question part B, solve the equation where 4 sin theta equals to square root 3 secant theta for the range 0 degree less than equals to theta less than equals to 360 degree. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us start to solve the question part A. Okay, if you take a look at the question part A, it is involving the proving concept where left hand side should be equals to right hand side. Okay, you can choose any one of the side guys to solve. But in this case, I'll recommend you to choose the left hand side because it is easier for us to solve the complex one and then you simplify it, rather than you choose a simplified version and then you expand it into a complex version. Okay, so from here we're going to pick this left hand side equation to solve. So let me write this equation in our working here. So from here, 2 sine in the bracket 45 degree minus x, okay, close bracket, cos 45 degree minus x. Okay, by the end of this working, you should get your equation equals to cos 2x. That is the one we're going to find out, guys. Okay, so from here, let us start our working. So if you take a look at this equation itself, it is involving a compound angle formula. Okay, so if you don't know what is the compound angle formula, okay, let me show you in which part of this equation involves the compound angle formula. Okay, the first one is involving this equation where sine in the bracket 45 degree minus x. So this is the first compound angle formula that we can found here. So in this case, this sine 45 degree minus x is representing the formula sine in the bracket A minus B. Okay, so this is the first compound angle formula. Okay, and this will be your second compound angle formula where cos in a bracket 45 degree minus x. Okay, so this cos 45 degree minus x is actually representing the formula cos A minus B. Okay, so this sine A minus B and cos A minus B, the full derivation I have shown you in the compound angle formula list, guys. You can take a look at the compound angle formula list which I'm showing to you right now, so you can use that as your guidelines in order to solve for this equation. Okay, I just want to pinpoint which is the compound angle formula in this equation. Okay, so I hope you guys identify it. So from now, let me remove this. Okay, so from here what you're going to do is we're going to start to solve the compound angle formula one by one. Okay, so it's going to be a tedious working, so please stay with me, guys. So from here, 2, okay, let me put a big square bracket because it's going to be a long working. Let us start to solve this first compound angle first. So from here, sine 45 degree minus x. So from here, you solve this, you should get sine 45 degree. Let me put a back bracket here. Sine 45 degree and then times with cos x. Okay, minus with cos 45 degree sine x. Okay, close bracket. So from here, this is the expansion based on the first compound angle formula, guys, which is sine in the bracket 45 degree minus x. You should get this first expression. Okay, so from here the first compound angle we have already expanded. So let us proceed to the second compound angle, which in this case is cos in the bracket 45 degree minus x. So from here, when you expand this, you should get, okay, let me continue over here, guys, since it's a multiplication and it is too long. So let me continue over here. So from here, in a bracket, cos 45 degree, okay, times with cos x plus with sine 45 degree sine x. Okay, just in case if you get confused, okay, let me erase this. Okay, and draw another square bracket over here so that you guys can get it clear. Okay, so this expansion, I don't just simply write it, guys, it is based on the compound angle formula. Okay, so from here we have already expanded the second compound angle formula, which is cos 45 degree minus x. So this is the expansion from the second compound angle formula. Okay, so from here what you're going to do is, if you take a look at the expansion over here, you can see there is a angle over here, which is sine 45 degree, cos 45 degree, and cos 45 degree and sine 45 degree. Okay, so this value we can express in numerical form. Okay, if you recall this triangle concept, okay, let me draw a triangle, guys, so please wait. Okay, so let's say, for example, this side you have 1 in length and this side you have 1 in length. So from here your hypotenuse will be 1 square plus with 1 square and then you square root. So from here your hypotenuse will be square root 2. Okay, and your angle will be 45 degree and 45 degree respectively. Okay, this first angle will be 45. Okay, and the second angle will be 45 as well. Okay, and then you have a right angle over here, which is the 90 degree. Okay, when you sum them up together, you should get the total of 180 degree. Okay, so that is the basic concept over here, guys. Okay, for example, let's say if you want to find the sine 45 degree, okay, the formula to find the sine 45 degree, okay, will be equals to opposite over hypotenuse. Okay, in this case your opposite is 1, okay, and then your hypotenuse is square root 2. So 1 divided with square root 2. Okay, so this is the value for sine 45 degree. Okay, and then continue with cos 45 degree. Okay, your formula to find the cos 45 degree will be adjacent over hypotenuse. Okay, in this case this is your adjacent 1, okay, and this is your hypotenuse, which is square root 2. Okay, which basically is just the same value, guys, of sine 45 and cos 45. Okay, I'm showing this just in case if you don't know how you get this 1 over square root 2. Okay, just want to make you guys clear about this. So what we're going to do is we're going to include these values into our equation over here. That will be our next step. Okay, so let me erase this. Okay, continue to our next step. So from here to, okay, let me put a big square bracket over here. Okay, so from here sine 45 degree will be 1 over square root 2 times with cos x, okay, and then minus with 1 over square root 2 times with sine x. Okay, close bracket. Okay, and then continue with the second expansion. So cos 45 degree cos x will be 1 over square root 2 cos x. Okay, let me write this properly. Cos x plus with sine 45 degree, the value is 1 over square root 2. okay, and then you times with the sine x. Okay, so let me adjust this sine x. Okay, so please wait. Okay, let me close the bracket. So from here, if you take a look at this two expression over here, it is recalling the conjugate. If you don't know what is the conjugate concept, okay, let me explain to you. A minus B, you times with A plus B, you should get A square minus with B square. Okay, you straight away get this expression. Okay, this expression is the one we are encountering over here. This A minus B is resembling the 1 over square root 2 cos x minus 1 over square root 2 sin x, and this A plus B is resembling the 1 over square root 2 cos x plus with 1 over square root 2 sin x. Okay, so we no need to do the long expansion working. We can just straight away use this conjugate concept to get the working answer, guys. Okay, so from here, let me just erase this. So we're going to perform the conjugate over here. So from here, when you times this, so from here 2, okay, and then you times with the square bracket. So from here, we start with the A square. Okay, the A square will be 1 over square root 2 cos x times with 1 over square root 2 cos x. So from here, you should get 1 over 2 cos square x. Okay, so this is the first expression. Okay, and then followed by negative 1 over square root 2 sin x, and then you times with 1 over square root 2 sin x. So from here, you should get is minus 1 over 2 sine square x. Okay, close bracket. So for the next step, what we're going to do is we're going to factor out the 1 over 2. Okay, so from here you factor out the 1 over 2. 2, okay, you times with 1 over 2. Okay, and then you left with cos square x minus sine square x. Okay, since you already factor out the 1 over 2, guys. Okay, so from here, this 2 and 1 over 2 you can simplify. Okay, you only left with 1. Okay, so from here, if you take a look, this expression, it gives us the expression of cos square x minus sine square x. Okay, this cos square x minus sine square x, you can find in the double angle formula concept, guys. Okay, if you don't know what is the double angle formula, I'm going to show you right now. So this is the list of double angle formula. Okay, if you take a look at the double angle formula, this formula fulfills the expression of cos 2x. Okay, so from here you already get the expression of cos 2x. Okay, so we have already successfully proved that the equation of left hand side is equals to right hand side. Okay, so let me underline the solution for the question part A. Okay, so from here, let me proceed our discussion for the question part B now. For the question part B, we're going to solve the equation where 4 sine theta is equals to square root 3 secant theta for the range 0 degree less than equals to theta less than equals to 360 degree. Okay, so what we're going to do is we're going to write down this equation into our working here. So let us start. So from here, 4 sine theta is equals to square root 3 secant theta. Okay, so from here, let us continue our working. Secant theta can also be expressed as 1 over cos theta, guys. Okay, so from here, our next step will be 4 sine theta will be equals to square root 3 times with 1 over cos theta. Okay, let me write this properly. Okay, so from here, for the next step, what we're going to do is we're going to times cos theta in the both side. So from here, you times the cos theta by both sides. So from here, you should get 4 sin theta cos theta is equals to square root 3, or you can just use this cos theta at the denominator and then times over here. That's also can, guys. Okay, so from here you get 4 sin theta cos theta is equals to square root 3. Okay, I don't know if you guys notice or not, but I can relate this expression into the double angle formula. Okay, which in this case is sin 2a is equals to 2 sin a cos a. Okay, so from here, how can I relate to that particular double angle formula? So what I'm going to do is I'm going to factor out this 4 by 2, guys. Okay, so from here I factor out 2 from here, so I left with 2 sin theta cos theta is equals to square root 3. Okay, as I mentioned, sin 2 theta is equals to 2 sin theta cos theta. So from here I can just substitute this expression into sin 2 theta. Okay, so from here you get 2 sin 2 theta is equals to square root 3. Okay, so from here up until now, I hope you guys are clear about this. Okay, this step until now, I hope you guys understand. So from here onwards, you need to be slightly careful, guys. Okay, so from here, to find the sin 2 theta, okay, the square root 3 you divide with 2. Okay, so from here, sin 2 theta is equals to square root 3 over 2. Okay, so to find the 2 theta, what you need to do, you need to sin inverse square root 3 over 2. Okay, if you take a look at this expression, square root 3 over 2, okay, we can form this value based on another triangle identity. Okay, if you don't know what is the triangle identity, okay, please wait for a moment. Let me draw the triangle now. Okay, so from here, this length will be 2 and this shorter length will be the 1. Okay, and this vertical length will be square root 3. So from here, this angle will be 30 degree. Okay, and then followed by this angle 60 degree. Okay, and eventually this is the 90 degree angle. Okay, you sum all the internal angle, you should get 180 degree. Okay, so it is a simple concept. So this is the triangle identity I'm trying to show you guys. Okay, so from here you can easily find the angles, guys. Okay, which is correspond to square root 3 over 2. Okay, in order to find the 2 theta, what you do, you sin inverse square root 3 over 2. Okay, so from here we need to find the value correspond to the sine. Okay, so in this case, to find the sine will be opposite over hypotenuse. Okay, so this is your opposite, in this case square root 3, and this is your hypotenuse, which is 2. So which angle correspond to this opposite over hypotenuse? This 60 degree, guys. Okay, so this is your first value you can obtain. So from here, 2 theta will be equals to 60 degree. Okay, but now you need to be really careful, guys. Okay, because the question mentioned that your answer must be in between the range of 0 degree and up to 360 degree. You can get the sine value positive in the first quadrant and you can get sine value positive in second quadrant. Okay, so from here, to get the value of second quadrant, what you do, 180 you minus with degree. Okay, so that will be your second angle. Okay, and if you think that you can just leave this answer in these two solution, okay, you are totally wrong, guys. Okay, why am I saying so? These two theta meanings that your angle has been revolved 2 times, guys. Okay, for example, your angle has been revolved 360 for 2 times. Okay, let's say this is your axis. Okay, you start from here and then it moves anti-clockwise. Okay, 1 time. So this is one complete round and then it's moving to the second round. So this is the meaning of 2 theta, guys. Okay, so from here, since you're having the value of 2 theta, you need to include another 2 more values in corresponding to this 2 theta. So how are you going to do that? So 360 degree, you need to plus with this 60 degree angle, because 2 theta indicates that your angle has been revolved 2 times. Okay, so this will be your third solution. Okay, so from here 180 degree minus 60 degree, you should get is 120 degree. Okay, so from here 360 degree, you plus with 120 degree. Okay, so from here you calculate this 2 angles. So from here you should get 420 degree and 480 degree. Okay, so this working, we can just remove them. Okay, but this is not your final answer, guys. Okay, we just find 2 theta, the value of 2 theta, but then we need to find the value of theta over here. So to find the value of theta, what we need to do, we need to divide the value obtained by all the angles by 2, guys. Okay, so from here, when you divide all the angle by 2, so from here you get 30 degree, 60 degree, 210 degree and 240 degree. Okay, so this is your final answer, guys. So let me underline the solution for the question part B. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.